Yes, welcome everyone, and in today's video we are going to share about automating temperature. So temperature is one of the most common systems we have to automate. That is, like, you think about your AC, your refrigerators, electromagnetic heating, you think about cooling and heating of the space, you think about food processing industry. Some of the times you need some particular thing at one particular temperature, so you really have to dig deeper, and this is a project that can help you all through. So I'll just give you a simple project of, like, maybe some farmer has a brooder, and instead of using charcoal to maintain temperature for these young chicks, they are using like heating bulbs or filament bulbs. So you have to bring in this. So this is a temperature controller whereby it is having two inputs of powering it and two outputs of powering the system. So this is its sensor. So most of the times whenever you're dealing with the sensor, you try to know the basic principle behind the operation of the sensor. So this is a thermocouple based temperature controller. You can find out a resistance temperature detector, that is RTD, which is positive, or you can go to an NTC thermostat, or you can find there are a whole bunch of many sensors out there of temperature. So this is one, and this is one I have to introduce you because I bought it around like 10k or 15,000, so it's something that I can use. So now the project is, maybe you want to maintain the temperature. The veterinary doctor has told you your chicks have to be at a temperature of 40 degrees Celsius or maybe 37. So this one can help to keep, as long as you just set your temperature. But they are all cost effective and cost friendly. So one of the video I'm making, this one is just to connect directly to the bulb without a PLC. And those guys who are freaks that are interested in PLC programming, still I'm also making the same. So I'll connect this as well to the PLC. Maybe if you're thinking of a larger project and is having very many inputs and outputs, still we can connect this to the PLC, and then we control our system or our plant. Let's dive into connecting it without the PLC and then after with the PLC. Thank you.
Hello, so real quick, this is the schematic diagram. We are having the input from the red and black wire, and then we supply the output from the yellow and black wire. So from the input side, of course, is AC, and then from the output side as well, it is AC. So if you are setting up the temperature and you want it like 37, you hit your 37, and then you have to put the stock temperature at 39.5. This is to give the gap of operation. We don't want you, whenever you're at 37, to turn on and off like that. On and off, we don't want it to be frequent, so you give the 2.5 degrees Celsius of your bandwidth. So depending on the process and the temperature and how fast.
So apparently for me, I have set the temperature at 33. That's the desired temperature that I need, because it's the one that I can achieve with my body. And then I want that whenever the temperature goes less than 32.5, I should start my heating, and whenever the temperature is above 33, I should keep my heating on. So now I'm gonna be in heating mode. So I'm going to raise my temperatures. I'm going to just put the thermocouple inside my mouth. So you can see the bulb lighting, and once it starts lighting, immediately I have removed the thermocouple from my lip, and now again the temperature drops. So so a little bit you need to know about temperature control. Temperature control, normally when you want your temperature to be at a specific value, let's say 30, you don't need it to come in and come off whenever it is at exactly 30. So we always give a band region. Like if you want your temperature to be at 30, that means you have to set the upper limit as like 31.5 and the lower limit at 29. So as whenever the temperature gets to 30, you remove this act of going on and off immediately. Whenever it is at 30, it comes on, and whenever it is below 30, immediately it comes on. Like that triggering of the signal, maybe if you're using a relay or you're using a bulb, it will always be like flickering. So whenever you're using automation, maybe in terms of like heating, you want to turn the heater on or you want to turn it off, you always give that bandwidth of like maybe 2 degrees. So if it is at 30, it does not turn off the heating. It will just heat until it is like 31.5, and whenever it is off, and it gets back to cooling level. Whenever it is at 30, it does not immediately turn on the heater, but it will rather turn on the heater at like 29. So that's the logic in control of temperature. Thank you.